Всем привет! Сегодня мы снимаем обзор на парк в Дубае. Пойдемте посмотрим, что здесь есть. На улице сразу есть фонтаны, а при входе нас встречает вот такая красивая фонтан. Проходим туда. Здесь мы можем взять билеты. Вот карта. А вот здесь небольшой макет. Светящийся. Здесь самые маленькие детали даже сделаны. Человечки. Все светится. Здесь можно почитать. Прочитать, сколько дней, и поставить лайк. Здесь вот такой необычный, видимо, ракеты, магазинчик. Вот здесь есть много панелей очень солнечных, и здесь 5000. Вон там вдалеке зеркало, и там много-много зеркал вокруг него. Эти зеркала направляются на эту башню наверх, а там уже солнечные батареи собирают много энергии. За счет этого производится сразу больше энергии в одном месте. Теперь мы вам покажем всю экскурсию, как будто бы вы побывали на ней. Ставьте большие пальцы вверх и подписывайтесь. Мы зашли в кинотеатр небольшой, и здесь будет у нас небольшое видео.
Dubai is the land of dreams, ambitions, achievements, new visions, and outstanding model of gateway to knowledge for the future. In accordance with the vision of His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, to enhance the Emirates' position as a global hub for green energy and green economy, and as part of the UAE Centennial 2071 and the UAE Energy Strategy 2050, Dubai established the Innovation Center at the Mohammed bin Rashid Al Maktoum Solar Park, a new icon in Dubai and a global hub that brings together creativity, innovation, knowledge in order to build Emirati caliber and empower the next generation of leaders within the clean energy domain. It builds strong partnerships with universities, research centers, and startups in innovation and knowledge sharing. The center's goals focus on innovation, education, and inspiration. The center provides more than 30 interactive displays on DIWA's journey, and also the most prominent inventions in electricity, as well as the latest developments in renewable and sustainable energy. The exhibition area includes several sections. The first section displays the history of DIWA and the evolution of technology for the generation of electricity and water. The second section highlights the properties of light and the components of the light spectrum. The third section focuses on solar energy-based technologies and its evolution over the years. The fourth section focuses on the future of energy and the possibilities for further exploration. The centre includes labs, training halls, lecture halls and a knowledge centre in addition to a state-of-the-art exhibition hall for various displays such as holograms and drones. The centre also includes labs for brainstorming and creativity with a view of the Mohammed bin Rashid Al Maktoum Solar Park. The Innovation Centre received the Platinum rating by Unit, achieving the highest score in the world for a new government building. The building covers 4,355 square meters and is 88 meters high. The Innovation Centre at the Mohammed bin Rashid Al Maktoum Solar Park, a new addition to DIWA's track record of achievements in renewable and clean energy. Starts here.
The first section where we are right now, it represents the history of DIWA and history of electricity. Speaking about DIWA, this is the utility company here in Dubai, the company responsible for generating the electricity and of course desalinating the water for the use in Dubai only. Okay, the total installed capacity here in Dubai is almost 13,000 megawatts. The solar park is almost 8%, which is almost 1,310 megawatts. The plan is to go to 5,000 megawatts by 2030. So this solar park by 2030 will generate almost 5,000 megawatts. That will contribute with 25 to 30% of the total Dubai electricity. And there's a vision which is by 2050, Dubai will be 100% clean energy. So all the sources will be used to generate electricity in Dubai by 2050 will be from a renewable source. Okay. At the moment, we have two main sources to generate electricity. Okay. Whether the electricity generated from the solar park or from the Jabal Ali gas station, we step it up to 400 kilovolt. And this is a view of the main grid, the high voltage grid. This is the grid that takes the electricity from the source and distributes it to the city. Then once they get closer to the city, they step that down to the subsidiary grid, which is 132 kilovolt. This is the grid that takes the voltage or the electricity and distributes it inside the city, and then they start to do the step down according to the requirement of the residential area or the buildings. We have a view here. This view here, it represents the distribution of the substations all the way around Dubai. So this green dots is to represent the substations or the transformers responsible for the step up and the step down. And this area right here is the Jabal Ali gas station, right? Since DIWA is also responsible for the desalination of the water, we have this view for the water lines. And almost more than 99% of the water we use here in Dubai is from the desalination process. And Dubai uses now the reverse osmosis as a new technology for the desalination process. This technology is very, very efficient, requires less electricity, and the water coming or the salt coming, when they distribute it back to the sea, it has a less side effect on the marine life. Okay. Later on, I will give you some information about the desalination process or the reverse osmosis. Okay. This section here, it is more about history of electricity. Well, we have a lot of equipment from the history of electricity. So we have here the plasma globe, which is one of the Nikola Tesla inventions. We have here the Van de Graaff electrostatic generator. We have the Tesla coil. And of course, this screen here, it has a presentation about the distribution of the electricity, or actually the journey of the electricity from the generation until the distribution board. Since there's a lot of stuff around this section, I'm going to give you some free time here. You can go through it, you can read, you can discover it. You can get like 10 minutes to walk around the section, and then I will take you to the next one, all right? Okay.
How much megawatts did you say is from there?
1,300. So 5 gigawatts from one solar farm is a lot. Now it is or not, but by 2030, 5,000 gigawatts.
Press the button to start. And then step 2. I don't know, I don't want to get electrocuted.
Do you know how it works? Do you have an idea?
No.
No? Alright, let me tell you. So technically when you move this build, so this build here, when it moves, it generates a static energy, right? That can be detected by this receiver here. So you see this is spark, this here, this is actually voltage, this is electricity. So when we increase the speed of the build, we increase the percentage of voltage generated. So it can go up to 5 megavolts. When you go to speed to the maximum, it can go to 5 megavolts, okay?
Mm-hmm.
So this is technically how it works.
Назвали единицу измерения.
Время.
Ага.
Тебе
Записать тебя?
на записи. Сначала разноцветное, включаем, оно белое.
Класс, почему так?
А потому что все цвета же равняются белому, а мы их видим очень
А то
быстро.
что,
и
лампа
мы-
загореть
А
будет?
здесь да, просто. Здесь. Штука, которая электричество производит.
You see this?
Вверх.
Почему имеется?
Technically, this is called a Tesla coil. With a low voltage, this coil increases the magnetic field and the voltage are coming out of it that can be detected as a wireless electricity.
Чтобы было волшебно. Да, смотри. Одной стороны загорелась.
А, даже так?
Да.
Почему?
Я не поняла.
Да, там сейчас понял.
Здесь солнечная батарея. Хотя она здесь показывает, сколько энергии. Здесь можно крутить, можно производить энергию. Таким же способом работала вот такая машина, которая тоже производила энергию. И вот так работает современный двигатель. Там находятся две части, и они вырабатывают разные частицы. Они начинают как магнит отталкивать друг от друга вот эти, находящиеся внутри. Таким образом стержень крутится и приводит в движение. Мы можем раскрутить. Не знаю, что это. Думаю. Мы это включаем. И вот сколько может произвести вот такая машина. Непонятно. Здесь у нас за счет преломления света получаем вот такой эффект. Каждый свет, вы видите, то здесь что-то здесь не будет, здесь нет. Вот такой изобрели аппарат. Это, видимо, был практически первый микроскоп. Вот еще различные штуки, с помощью которых измерили микроскоп. Вот части современного двигателя. Здесь
Разные полярности эти.
видим.
Так, это где? Попробуй вот эту штуку, тебе понравится, записывай.
Прикольно.
Ой, ой,
Как красиво.
опасная штука.
Там между двух этих проходит электрический ток по воздуху. Тут есть разные.
Ой,
Что это? Здесь можно переиграться. Слушали, здесь есть электричество внутри шара. И оно реагирует на нас. Там видите,
Right, so since DIWA is also responsible for the desalination of the water, so we have this presentation here. It allows us to understand the process of the reverse osmosis. As you can see, it consists of 6 different steps. The first 3 steps where we push the water through the pipes that push the water through against the osmosis, and that filters the water from the solid material. Then step number 4, where we use very, very high pressure membranes to filter the water from the minerals. Step number 5, this is where we add the minerals to water to achieve the drinking water guideline. And then we start to add chemicals for disinfections, and then we start to distribute it to the drinking water things. Okay. Currently, Dubai is building a station in Hisyan that will use gas and desalinate the water 100% through the reverse osmosis. And the water meter available in Dubai currently, it's 100% digital. So you will no longer send people for the readings. And due to the digital or the smart communication system available in the houses, the customers can track their consumptions every 15 minutes. Because of that, in case if there is any leakage, the customers receive warnings to let them know that there is something wrong is going on. Also, you can use the application nowadays to compare their consumptions with their neighborhood. The communication system I'm talking about is the one right here.
получается.
да.
Ага.
So, now closer please. Cool. So in this section, we have different experiments related to the light and the light spectrum, and how the light interact with different sources. So before we go through a lot of details, I'm going to make this experiment to you that introduce the content of the light to you. So this white light that we see, it actually consists of different waves, and due to the wavelengths, we have different specifications. So the longest wave is actually the radio waves with a wavelength up to 100 millimeter. Then we have the microwaves, and we have the infrared, and then we have the visible light. Red color is the longest radiation that our eyes detect. And then we have different colors with different wavelengths till we go to the violet. And then we have ultraviolet, X-ray, and the gamma ray. This is something that allows the scientists to work on the efficiency of the solar panels. I mean, there is different types of solar panels. Thin film, polycrystalline, monocrystalline, multi-junctions. The most efficient one is the multi-junction, which is almost 47% efficiency. This one is almost used in the satellites and the spaceships. The most famous one that people use in their houses and or for commercials is the crystalline one, the silicon one. Okay, this is the efficiency of the most efficient solar panels out of silicon, can go up to 27%. Okay. We also have a thin film, which is the lowest. It's almost 21, 23%. Okay. And I mean by this percentage is the availability or the efficiency of the light observed by the solar panel and then used to generate electricity. Okay. In the solar park here, at this moment, we are using almost 5 million solar panels. Difference between thin film, polycrystalline silicon, and monocrystalline silicon. Okay. In the section right here, to the right side
is bifacial.
So we also have bifacial, but it's still silicon. So it's a monocrystalline silicon and it's bifacial. Okay. Later I'm going to show you examples of the bifacial ones. So before I let you go around the section, right here at this side, we have some information about the development of the solar energy through years. But also we have some pillars that explain how from the silicon cell we can build the silicon solar cell. Okay. Get some time also around that section, get some information. I will be waiting in the next one, all right?
Когда находилась здесь, вот эта
What is it doing? Is it just changing the light, or is it actually like moving those?
I think it's moving those and then those.
Oh yeah, I think you're right.
So we can understand the concept of the photovoltaic effect.
Он говорит, видел, как смотри, получается из песка, из силикона
See this little thing
делают.
swirling here? This is the photon, which is the content of the light. And then this pillars here, they represent the solar cell. So the solar cell, the way it was built, it has an N5 and P5. So when the photon hits the solar panel or the solar cell, it increases the flow of the electron from N to P, from P to N. So this flow generates electricity. So more light means more flow and then more electricity.
А? Нет, просто.
Вот это, наверное, они.
I was speaking to them about this is an experiment. We do it for our visitors, especially the kids, to allow them to visualize the photovoltaic effect, which is the method used to generate electricity from the sunlight. So this little things on the floor represents the light. And this pillar is going to represent the solar cell. As you can see, the solar cell, it has two regions, N, P, P5 and N5, positive, negative. So when the sunlight hit the solar cell, the electron, the silicon, the electron, the silicon is flow from the N to P, and this flow generates electricity. So more light means more flow, and means more electricity. So this is how a solar cell generates electricity. So, come closer please guys. We have a presentation here which is very interesting.
In Abu Dhabi. Not here.
Dubai did not set up anything or did not discuss anything related to the use of the nuclear. It's only in Abu Dhabi.
And then energy storage. Is there any plans to complement this plant with energy storage?
We are working on a pilot phase for building batteries that can be used for energy storage. And 4 days ago, Cuba announced that the
Перегрелась. Она прям написала и отрубилась сразу. Вот в прямом смысле она просто нагрелась, она горячая. Сейчас. Интересно. Работает. Это разработанная форма такая для винтов, чтобы из воздуха получать электричество во время ветреной погоды. Это один из спутников, модель его, который запускался. Он, видимо, полноразмерный. И еще один похожий спутник.
That's one of the satellites, a replica of a satellite that has been launched recently by Obzor to space. And then this table here, it has some information about different projects that can be considered as a renewable energy.
Кладешь и двигаешь.
Можно просто посмотреть. Смотри, какая зарядка. Какая зарядка. Зарядная станция. Машина заряжается.
This is about the green buildings available in Dubai. So technically you have almost 6 to 8 green, 100% green buildings, and this innovation center is one of them. However, Al Shura building, which is the new headquarter of Diva, is going to be the biggest green building in the world, and for the first time we use wafers or solar panels that can set up technically vertical, and that can provide a very high efficient energy.
Are you gonna use is Diva gonna use solar floating panels on the
There's no discussion. If you're ready, you can move to the third floor.
Такая прикольная. Вот ветер. Управляете ветер. Здесь различные. Чего?
Интересно?
Да.
Hello? Come closer. I'm gonna give you some time in a bit. So this presentation, it allows us to know the differences between different type of solar panels. Okay, so this is the most famous one. This is the silicon-based solar panels. As I said, we have different models of silicon solar panels. We have the polycrystalline or the multicrystalline silicon and the monocrystalline silicon. This one is the most efficient one, especially the bifacial one that can go up to 27% efficiency. The silicon itself, it has advantage and a disadvantage. The advantages that we have is very high quality, low defect, and high efficiency. We saw 27%. However, there is one challenge, which is the material used to build the silicon-based solar panels is consumable. Okay. Before using the silicon, the one that was famous before it was the thin film. Okay. It's very cheap compared to the silicon, and the efficiency is not very bad. It can go up to 23%. Okay, as a very efficient model. Okay. However, there's some challenges we face with the thin films, that some of the material used to build it is toxic. Okay, but again, it's still a very low, cheap model, and the material itself is very strong in the utilization. Here is the multi-junction one, which is the most efficient solar panel that consists of different materials to increase the percentage of the light observed by the solar panel itself. The efficiency of that one in a cell can go up to 47%. But due to the cost of the multi-junction, which is very, very high, it only used in the satellite and in the spaceships. Still cannot be used in a big field like a solar park. Okay. Other issue, which is the material used to build it, it's rare. It's not available everywhere, and of course some of the materials is toxic. Okay. Related to the challenges that we face in the solar park, there's a lot, especially in this region in the Middle East. The most important one is a very hot temperature. When the temperature is above 40, the efficiency of the solar panel reduces very bad. Okay. This one we're still working, which is the heat, is still working on different technologies, so we can keep the solar panels within a certain temperature and to avoid the efficiency is in a good shape. Another problem, which is very, very challenging one, is the shading issue. And in this region, the shading here is the sandstorms, especially in summer, when we have humidity at night and then sandstorm. So the sand stuck on the solar panels to create shade, so the efficiency dropped so bad. And due to that, we started to use robots. Okay, this robots moves to wipe the sand off, and that happens almost at night. We do the cleaning of the solar park here once every 7 days, 7 to 8 days. But once we have a sandstorm, we might clean it every 3 days. Okay. Another issue, which is the cloudy. So whenever there is a lot of clouds covering the sun or the sunlight, the efficiency of the solar panels drops. But such an issue is not so big here in this region compared to the other issues like the heat and the sandstorm. Okay. So if you want to see examples of the solar panels, the first one, this is the thin film. This is the polycrystalline silicon half cut, and then we have the monocrystalline silicon bifacial, monocrystalline silicon half cut bifacial. Okay, again, almost 5 million solar panel available in the solar park, 2.3 million thin film, and almost 3 million from polycrystalline, monocrystalline, and monocrystalline bifacial. The most efficient phase in the solar park is the third phase, that we have the ability to generate until this moment from the third phase 800 megawatt with the cheapest level cost in the world, 2.99 cents per kilowatt hour. It's a very, very cheap rate. Okay, and the efficiency, as I said, 800 megawatt is due to different factors. In the third phase, we use for the first time the tracking system. We use the robots for the cleaning, and some of the robots works automatically. They connect and dismantle themselves automatically without interference of human being. Some of the solar panels, they require the workers to connect and disconnect them from the solar panels. Okay, so until this moment, we have only 3 operating phases: first, second, and the third. The fourth phase, we are expecting to operate it by the end of this year, if everything goes well. The fourth phase is also very efficient due to the different technologies we are using in the fourth phase, which is the concentrated solar power. The expectation from the fourth phase is 950 megawatt, with a level cost can go up to 7.5 cents. But 7.5 cents is very expensive compared to the third phase. But the third phase, it only operates during the day. However, the fourth phase, and because of the CSP, they will operate during the day and at night. Okay, let me show you how. So until this moment, everything is clear, right?
Yes.
Cool. So the CSP, we have two different systems. This one called the parabolic system. We have almost 63,000 parabolic system available in the solar park. The way it works is as you can see here. The mirrors are scattered with a tube in the center. We store in this tube synthetic oil. Due to the temperature that can go up to 400 degrees, this oil will start to boil. So we will direct it to the heat exchanger where we have the water. The water will start to evaporate, so the steam will be collected and pushed to the steam turbines, where the turbines will start to spin to work during the day and of course at night due to the thermal heat and the preservation of the steam and the heat. So that product can work for almost 15 hours, okay? For 15 extra hours, so it can work and provide electricity at night. 600 megawatt is the expectation from this project. The other one is the solar tower. This solar tower is the biggest and the tallest solar tower in the world, almost 250 meters high. 70,000 mirrors available around the solar tower to reflect the rays of the sun to the receiver on the top there. We store on the receiver salt, okay? So due to the temperature, the salt will melt. So we will direct this molten salt to the tanks available under the tower. This tank can preserve the heat for like 15 hours. So from there, we will direct the thermal heat to the heat exchanger where we have the water evaporation, steam to steam turbines, and then we will start to generate electricity. 100 megawatt is the expectation from this project. So from CSP, it's almost 600 megawatt. And then the rest, which is, 700 megawatt from the CSP. And then 250 megawatt is going to be from the photovoltaic effect or the solar panels, to be in total 950 megawatt in the fourth phase. The fifth phase, last year we started phase A, where we were able to use the bifacial for the first time in the Middle East. And the project succeeded, and we were able to generate almost 300 megawatt from the solar panels installed at the station A on the fifth phase, with a level cost almost 1.9 cents per kilowatt hour, okay? And still the fifth phase is under the setup. Again, the expectation from the solar park is almost 5,000 megawatt, and that will be ready by 2030, right?
Do you use white surface under the bifacial panels?
I think sand.
Planning?
No, just sand. Because sand is still the second on the list after the snow.
Yeah,
the reflection of the light. So sand is still a very high percentage to allow the sun, two photons to bounce, to be captured by the solar panels.
Great. The albedo is high.
Right. Do you want me to give you more time in that section before we move forward?
Sure.
Yes.
I used to work at the tracker company that does startup.
Он в машине?
Кепку, ну сейчас не нужно.
Reflected ground.
Right. So, as I said earlier, Dubai is planning to go to 100% clean energy by 2050. So there is a lot of other projects still under construction, and some of them in the pilot phase, and they will allow Dubai to go 100% by 2050. The first project, like this one here, which is Shams Dubai, where DIWA will allow the customers to set up solar panels in their houses, and then they can generate electricity directed to the grid. So at the end of the month, they will deduct whatever they have consumed from whatever they have generated, and then they pay the differences. Okay? There's a lot of people who already have set up something like that, and we have a residential area, which is the Dubai Sustainable City, that gets almost 40% of the requirement from the solar panels available on the roof of the houses. Okay? Another project, which is still under construction, it's called the Hatta Hydraulic Power Plant. This
На третьем этаже есть небольшое кафе. Здесь можно что-то купить. Есть только но мне очень необычно сделана вот эта стена. Здесь как бы зелень внутри. На этом наш обзор парка в Дубае подошел к концу. Всем пока-пока.